Our next speaker is Liangjie Hong, Director of Engineering and AI at LinkedIn. He's formerly from Etsy and Yahoo. He has a PhD in computer science from Lehigh University. And I mean, guys, LinkedIn is a big part of our lives nowadays. Can you imagine without LinkedIn? So my term for him is the Jimbai guy. And if you're not familiar with Jimbai, that is jobs you may be interested in. Thank you.
Thank you for the nice introduction. And so the Jimbai is a product we build for the job you like, and super glad that a lot of you may heard about it and use it, and we also send email spams to you every day. So I also flew in yesterday midnight, so if I'm not super coherent, so sorry about that. Let's see, so this talk, right, so it's going to be slightly different than the previous two talks, and it's more focusing on one domain, right, so this is less about the generic machine learning. Hopefully I would love to convey you there's something very exciting happening, right, in this new field, what I call computational job marketplace. Yes, this is a super quick introduction about myself, right? I stayed in LinkedIn in the past 2.5 years. Before that, I was in Etsy and also Yahoo Research for a couple of years, all working around search and job recommendation domains, right? So this is my kind of expertise. And also in the past couple of years, both in LinkedIn and at Etsy, I'm heavily thinking about what machine learning can do for marketplaces. So that's something I think it's uniquely new. So there are three parts of this talk. The first one is that I want to motivate a little bit, like what do I mean by job marketplaces, right? So what's the unique challenges or the opportunities there. The second is that I would like to share a little bit about how we're doing that in LinkedIn, right? So what are the things we are building there and how far we have been go through the journey. The last but not least is that I think we're just scratching the surface of what type of problems we could solve. So we'll also share a little bit the ideas around what are the opportunities moving forward. So job marketplace, right? So that's very much strongly tied to the economy, right? Every time we hear about the report from economy newspapers and many different sites and also the the TV and so on, a lot of that is about job market, right? So how many jobs created, how many people are getting new jobs, how many people cannot find a job and so forth. So this is has always been a very central to the economy in the past hundreds of years, right? So this is what the job marketplace is about. In the past couple of years, there is a increasing trend. This marketplace is go online, right? So this job marketplace has been around, like I mentioned, hundreds of years, even not mentioning like thousands of years. But in the past couple of years, a lot of this is trying to go online, right? So the jobs are posted online, recruiters are finding candidates online, and so on, right? So this is a booming business in the industry, and this is already probably an old report I pulled somewhere online, right? So it's by 2027, it will be a 43 billion business. So a lot of money in it. Not only this is a trend that we are going online in the recent years. There's also another trend, right? So in the past couple of years, because of a global pandemic, the workforce and how we organize work, how we think about job, how we think about applying job and retaining a job and so on, has been dramatically changed, right? So like a lot of us work from home, a lot of us finding the jobs completely remotely. That's unbelievable before the pandemic and now become a new trend. So how can we embrace all these new trends in job marketplaces? That's something super interesting. And with all this trend, there is a growing number of companies I just named a few here, right? So, but there's definitely more are building tools, building platforms, building products in this large ecosystem and trying to help people, right? So finding their jobs, enhance their skills, and trying to kind of, boost this whole marketplace. The real challenge in this whole ecosystem is that how machine learning, how AI, right, so can help to match opportunities, right? There are so many different, segments. There are so many roles and people, different roles, different participants in this whole ecosystem. So how can we build system, right? So to be able to help them. I think that's the mission. That's a goal for a lot of those companies. So with that background, right? So I would love to jump in a little bit of how LinkedIn we are thinking about, building machine learning, building AI solutions, right? So in this domain. So a little bit, numbers, stats around LinkedIn, right? Every second on LinkedIn, there are roughly 100 job applications, right? People apply jobs on LinkedIn, and 21 emails, right? So those, special, messages you can send by recruiters on LinkedIn, right? So 21 emails sent on LinkedIn and 0.1 hires, right? So we actually, track how many people really get hired, change their job on LinkedIn. So that number is 0.1. As you can see, right? So this is a funnel, right? So this is different level of engagement and, attracting people, apply jobs, relatively easy, but really helping people get their job super hard, right? So as you can see, it's a different order of magnitude challenging. And real quick, right? So on LinkedIn, we have different products for different users. For job seekers, we have search recommendation functionalities that they can browse on the website. We also have alert, and we also have emails sending to large audiences as well. For hires, right? So for the recruiters, we also have search, recruiter search, and candidate recommendation kind of tools as well. So this is like on the high level, right? So how LinkedIn products, different offerings for these two distinct groups. And this, why we call it marketplace, right? So it's really not about one party. It's about at least two parties. In this case, job seekers and hires. They need to kind of interact, right? So they need to have a transaction in the end. In this case, it is kind of an interview, and you get an offer from the job from the company, and you eventually, right? So not only get an offer, you eventually actually join that company, right? So that's the two-way interaction, two-way interest of a marketplace, and that also make the marketplace problems inherently hard, right? Because it's not just one-way interest. And on LinkedIn, we actually track how many jobs, how many people changing their job via LinkedIn. That's what we call the confirm hire. That's something we track. That's something we kind of optimize for, right? So that's the idea. Well, confirm hire sounds great, but as I mentioned earlier, right? So like that's order of magnitude less data compared to other signals, right? So like applies or click and so forth. And also there are other challenges as well, right? So for instance, people change their title after they join the new company, or some folks, they never change the title. So we cannot really observe this confirm hire immediately, right? So it's delayed, it's sparse, and like I mentioned, also only partially observable. So that's adding different layers of difficulty that we can directly optimize confirm hire. Like I mentioned, right, so applications are cheap. So this is just one example where Royal Family posted a job a couple of years ago on LinkedIn and get, right away many different applications. So if we look at the distribution of applications and if we look at the distribution of confirmed hires, they are very different, right? So we cannot just optimizing for applications, we need to figure out a way that shape the application distribution such that we can maximize the confirmed hires, right? So that's the idea. Now, confirmed hire, directly optimizing confirmed hire are very difficult. So how can we do, right? So where can we start, right? One idea is that, okay, maybe that is hard. Can we find something is simpler, right? So can we find something, is easier? So this is the idea that we use a surrogate metric, right? The idea of a surrogate metric is that we find something is easier to measure, easier to be built, but it has a really nice correlation with confirmed hire, right? So in this case, what we call it is a predicted confirmed hire. So it itself is a model. We build a model, try to predict the confirmed hires, and this PCH can really correlate very well with confirmed hires. So then we have a confidence that, okay, so if we optimize PCH and if we observe up and downs of PCH, hopefully, right? So that will translate to the confirmed hire eventually, right? So this is also a paper we published a couple of years last year in Wisdom, telling more details about what this surrogate metric is about, right? So with the surrogate metric, can we just rank all the job by that metric, right? Because that's obvious since we already built the surrogate. Well, not exactly, right? Because when we build that surrogate, we may have information that is not available at the time, at the serving time, right? So this is a slight, this is a note on the differences where you build a predictive model to understand the data or some like insight, the model for data insights versus you want to build a model for serving time, for really like in production, right? So in our case, PCH model is great as a metric for monitoring, for tracking, for data collection, and so on and so forth. But it's not a great thing for production because it has privileged information. It has the information that is not accessible, right? It's not available at the serving ranking time. So this is why we cannot directly rank jobs by PCH. Before I go even further, right? So just to set a context a little bit, is that at LinkedIn we are using TensorFlow ranking for pretty much all of our production model, right? Previously we were using large generalized linear models as well as GPTT, but in the past 2.5 years, we migrated pretty much everything to the TensorFlow due to a lot of the modular development and we can plug and play in many things. I'll show some of the examples in a bit. So going back to that PCH thing, right? So because we cannot easily do everything just sorting by the PCH, one idea we had is that how about we utilize this idea of a teacher-student model where we train a student model, right? So trying to mimic, trying to distill the knowledge from this PCH model where we have the privileged information, but we don't necessarily have the access during the ranking time, right? So this is exactly the idea we built for this teacher and student model, trying to optimize the predicted confirmed hire or confirmed hire, but trying to distill information and knowledge from the teacher model. So this is inspired by a paper by Meta/Facebook a couple of years back, right? So this is the idea that, okay, how can we leverage the information from the teacher? So that's tell us a little bit of the background picture of how we optimize confirmed hire, right? That's what with the true north metrics we care about. Next, I will quickly talk about how we are also utilizing transfer learning, right? So I think the previous talk also touched a bit on that a little bit. On LinkedIn, because we have so many different products, right? We have job search, job recommendation, as I mentioned earlier, like alert and so on and so forth. So it's very hard to build models all from scratch, right? And it's very hard to maintain, and it's also very hard to go to productionize. One idea we have is that how about utilize transfer learning such that there's a leverage among different products, right? So then we can build the common pieces, jointly. So this is exactly the idea that we are applying transfer learning for a lot of the problems we have, right? So in this case is that we, no matter what product you are, right? So we build a shared understanding of members, a shared understanding of the jobs, and then on top of that, we learn the member and job embeddings specific, respectively, right? And then we have a product-specific, deep learning models, and those product-specific models are going to utilize the components, right? So then we kind of decoupled product-specific, learnings and the generic model components, separately, right? So this is the idea that we're using the transfer learning. A little bit background, right? So the features we are built on linking economic graph, right? So by economic graph, I mean a lot of different entities we extract from the data, and then we kind of build a knowledge graph on top of that, right? So there are a lot of numbers. We have the entities like members, companies, schools, and the skills. So these are the foundational kind of features we extract from the data. So with that knowledge graph entities, right? So then we feed those knowledge graph entities to different kind of entities we want to learn. In this case, members and jobs, and then we kind of learn their corresponding embeddings from this very traditional two-tower architecture, right? So this is a first generation of our transfer learning the embeddings. The second generation, right, so we also incorporated a lot of sequence into the learning, right, such that we don't have to learn everything from scratch. We kind of, sequencing the events. So I'm not going to details here, but you can check out the blog post we have. The third iteration of those transfer learning a lot of ideas, embeddings, right? So is to utilize BERT and a lot of the large language modeling out there, right? So we also recently migrated to transformer in this case as well, right? So we have building up a lot of capabilities for long text as well, right? So this is a third generation of how we are utilizing transfer learning for large scale text understanding. All right, so let's come back to that generic picture, right? So now we have the idea how we are learning the member and jobs embeddings and how the shared piece and the product specific pieces are fitting together. There's a last piece I want to quickly mention is really about activities, right? So everything I mentioned so far is looking at member profile data, job data, right? So those are more or less static, which is great, but we also want to take user activity into consideration, right? So one way we're taking that is to utilize the job seeker activity embeddings, right? So in one way we can stack kind of sequence all the labels, in this case, the actions, right? So you click on a job, or you apply a job, or you also save some job in your job alert. So those are the labels we gather, right? So then each label we could have the previous pre-trained embeddings, from the previous slides, right? So then we have a sequence of the embeddings, and using, in this case, CNN, but you can plug in many other ways to aggregate the data, right? Using some way to aggregate the data, we can have a model from the sequence of those embeddings to really learn what's the internal kind of representation. Sorry. what's the internal representation, right? So for the activities, and then we can sort of link everything together with the final next action prediction, right? So okay, based on your previous actions, how can we predict your next action, right? So this is the activity embedding kind of framework we have for our member and jobs. Now with that, right, so plugging that in the right corner, right? So then we have pretty much the full picture of how we are modeling everything, right? Now this sounds very complex, but as I mentioned earlier, right, so there are different pieces that train in different ways, right? So like a shared member and job embeddings trained in one framework, utilizing a lot of transfer learning ideas, and the member activity embedding training in another framework using this sequence modeling, and then on top of that, different product would have their specific DNNs to deal with that product, right? So there are quite a bit separated of concerns, and we don't have to train everything end to end from scratch, right? So this is the generic idea. So there are two topics I want to quickly touch on, right? So we're not expanding here. So far, I have been explaining the whole framework, the whole idea where we're optimizing what we call it organic pipelines, right? So basically is we want to optimize confirm hire, and then we use the surrogate PCH to really facilitate that the teacher and student model, right? So that's the organic pipeline we talk about. At the same time, we also have a promoted pipeline, right? So in a sense, is that it's like showing ads to you. That's very different than the organic pipeline, and there are many more layers on that. So I'm not going to expand in this talk, but I'm happy to chat offline with that. Another thing, right? So very quickly mention is that. In recent years, fairness, equitable result, and so on and so forth are very serious problems, and we want to tackle it very seriously and diligently, right? So at LinkedIn, fairness is building in a lot of our models. So in the previous slides, I showed all the components. We have monitoring, we have a feature parity, we have a lot of tools to build in to verify that we really have a fair outcome for different cohort of the users, right? So this is something we also care very much about it, but I cannot expand in details in this talk. Okay, so it's very quick, but hopefully I give you a high-level idea that how we are doing that in LinkedIn, trying to optimize confirm hires and outcomes, right? So are we done, right? So are we kind of just solve all the problems in this space? Well, certainly not, right? So as I mentioned, we are just scratching a surface. We have a lot of challenges and so on, right? The first challenge is that if we just look at the profile, right, and the job descriptions, sometimes we're going to end up with a lot of ridiculous and really bad recommendations, right? So we over the years we have been recommending janitors to professors, and interns to VPs. So there are a lot of the places we can improve, right? And on the left-hand side, this is a very recent complaint. Is a former executive from Google got a lot of off-chart kind of recommendations, and that person complaining in the social media, right? So, why we are doing this? Well, one of the why we are ending up with this, right? So one problem is that we just look at the tags, right? And in the tags, there are a lot of things can understand wrongly, right? So for example, if we extract, let's say, Microsoft Word as a skill, and coaching as something we want to match against the job descriptions, there are many jobs could end up with coaching, right? So like janitor, job might need a Microsoft Word, and the VP also have that description, right? So that's one of the things that we want to improve, is that not just look at the tax. We spend a huge amount of time understanding it through all these large language models, but really, how can we understand your career trajectory, right? Like, if we really look into the data and the transition of the different titles and jobs and the industries, so we might end up with much better way that we recommend jobs, right? So like thinking about how many VPs will transit to intern jobs, right? Very unlikely. So even though maybe they are in their job descriptions or the profiles, there are some tax similarities, right? So but on the transition probability, that's very unlikely. So that's something we need to think through, really how to understand that, right? So this is one challenge. The other challenge is that this is taking my personal kind of recommendation out there, right? So LinkedIn recommend a lot of directors' job to me, which is okay, right? So I'm a director of engineering now. There's no intern job there, right? But that doesn't help me transit to the next level, right? So how can recommendation inspire me go to my next level, my next adventure, if I just look at the similarity of the job and my profile, right? So that's something we also need to really understand the skills, right? So maybe there are other opportunities I can pursue now versus director of engineering, and some of the skills I acquire now can translate there, right? But we don't know those skills yet, right? So we look at more or less like on the text in a verbatim kind of a sense. So this is also something I think it's going to be super revolutionary, right? So in the next sense, and also typically for the for folks that they want to change their career trajectory, right? So then all the previous job titles, previous job experience may not be that relevant, but some of the skills would be relevant, right? So how can we help these users, understand, build up those skill base and also represent them, right, such that we can recommend better opportunities for them. So that's also something that I think it's worth to explore. Last but not least, right, so another challenge in this particular case, I searched a software engineer role in Mountain View, and all the results are from Meta, Facebook, which are, again, okay-ish result, but you would expect more diverse result, right? Now, what's happening here is that we don't necessarily really understand the demand and supply, right? Because this is eventually is a job marketplace, but as you can see in my previous slides, where we are doing here at LinkedIn is really doing a sophisticated tax matching and activity matching, right? But we are not taking into account how many jobs, are out there, how urgent the people are looking for jobs, those kind of marketplace indicators into account yet, right? So this is what I believe in the next big leap would be, is what we really take the supply and the demand from the marketplace into consideration, right? Thinking about how many companies will release their job completely randomly in a year, right? Very unlikely. Thinking about how many people want to find their jobs just randomly, right? So, across the year, very unlikely, right? So people want to find a job after, in a tech company, after 4 years, their stock option get a cliff, or they get just promoted or not promoted. There are many human reasons that want to find a job, right? And currently on the online job marketplace, we're not taking those into considerations, right? So I think that's pretty much the next biggest opportunity, is really look into those marketplace indicators and helping understand the supply and demand. So with that, right, so I'm kind of summarizing the talk, is that we really want to build the computational idea around job marketplace, right? So we are at the beginning of this job marketplace from offline and go online, and hopefully in the next couple of years, more and more people from the data science, machine AI can join this domain, and we work on the ideas that we can fully flourish this marketplace. So all right, that's all for the talk. Thank you.